हामी डेटा स्ट्रक्चर एन्ड अल्गोरिदमको हामी थर्ड सेमेस्टरको नोट हेर्नेछौँ। 24,169 जनाले पढ्नुभएको रहेछ। हामी यही नोट यसो हेर्नेछौँ। अब फाइनल प्रिपरेसन बिफोर द इक्जाम हो यो। अनि हामी स्ट्याक क्यू लिस्टहरू हेर्नेछौँ। Data structure is a way to organize the data in the some way so we can do the operation on the data in the effective way. Data structure may be organized in a different way, the logical or the mathematical model. Mathematical model or the particular organization of the data is called data structure. Choice of the data model depends on the two consideration. It must be rich enough in the data structure to mirror the actual relationship of the data in the real world. The structure should be simple enough that can effectively process data when necessary. Data structure can be classified as linear data structure, processing of data items by the linear fashion, or linear data structure, example array, stack, queue, linked list, etc. In case of stack, last input is the first output. Input process is called push, output process is called pop. In case of the queue, input process is called first output. First input is the first output. Input is called the rear. Output is called the front. In case of the linked list, start information. Ani the first part consists of information and second part consists of the pointer to the second block. A non-linear data structure. The data structure in which the insertion and deletion is not possible in a linear fashion is called the non-linear data structure. Example 3: student ID, name, address, branch name, yeah, free student name is address, street area, branch BEBCABIT, computer electronics. It is hierarchical in the nature. Ilam, Bhag, Viratnagar, Kathmandu, Nepalganj. Flight airlines contain the relationship between the pair of the element which is not hierarchical. Abstract data type ADT. ADT used to specify the logical property of the data type. It is the set of operation which is called with the component of an element that the abstract data types list ADT. The term ADT refers to the basic mathematical component concept that define the data type, item, operation, insert, and deletion. Search display. Here is an output of ADT. In ADT consists of the two types: value definition clause, condition clause, operation definition. ADT for relation of the definition. Abstract type definition: integer, rotational. Value definition: conditional, rational. Denominator is not equal to the zero. Abstract rational, make the rational a b, int a b, preconditional b, post condition, make the rational. ADT for the relation of the definition. Abstract data types define motive or integer rational. Value definition: condition rational 1 0, denominator is equal to the 0. Operation definition: abstract rational, make rational a b, int a comma b, precondition b, a post condition, make rational a, make rational 1. Abstract rational add a b, rational a b, post past condition a, add 1 a b. Abstract rational malt a b, rational a b, post condition malt a b b, malt a b 1. Abstract rational equal to a b, rational a b, post condition equal a b 1 b b 1. Goals of the data structure. Data structure involves into the two complementary goal: identify and develop useful mathematical utility and operation, and determine what class problem can be solved by using this utility and operation. Determine the representation for those abstract and utility, and implement the abstract operation of this concrete representation. Property of the data structure. Generalization. Utility: generalize the primitive data types. Integer data types: integer, real, float, encapsulation. All the operation of the data type can be localized into the one selection of the program. Stack is an order collection of the item in which the many new items may be inserted in which from which item may be deleted. One in called the top of the stack. Two operations are possible on the stack: push and add item on the stack, pop, delete the item, empty, push, push, pop, b, pause, C, pop, d. From the figure, we can see that the item inserted at the last of the first to be pop, deleted. Thus, the stack follow the last and the first are LIFO one or the first in last out FIFO policy stack of ADT abstract type definition data type stack data type define past condition empty condition for the empty abstract in type stack type variable declaration precondition empty condition for fulfill past condition pop length precondition stack push add new pop element stack it stack implementation array implementation linked list array implementation in array, we can push the element one by one from 0 to 1 position in the array position. An element can be added or deleted in any place. So we can push or pop an element from the top of the stack only where there is no place for adding the element in the array. Then this is called the stack overflow. So first we check the value on the top with the size of the array when there is no element in the stack, then the value of top will be -1. So we check the value before top, deleting the element stack array. Stack is implemented with the stack array. Size of the stack array is 7 and value of top is 2. Operation of the stack push operation: if top is equal to maximum -1, print app stack overflow follow else top is equal to top plus 1 stack arr top pushed minus item. Pop operation: if top is equal to -1, print f stack underflow else print popped element is percentage d stack here top. Algorithm for the push and the pop. Push, let the stack max size is an array for implementing the stack. Check the size overflow: if the top max size, then the print overflow in exists is set the top is equal top plus 1, increase top by 1, set the stack item, insert item into the new position, exist pop, check for the stack underflow: if top 0, then print stack underflow and exist, else remove the top element, set item stack top, decrement the stack top, return and deleted item from the stack, exist application of the stack, conversion of a expression from the infix to the postfix, evaluation of an arithmetic expression from the postfix expression, power, reminder, modulus, multiplication, division, addition, subtraction, conversion of infix to the postfix algorithm, add a unique symbol in the stack, and then in the array infix, scan the symbol of the array infix if the symbol of the left parenthesis and add to the stack if the symbol of the operand, and then add of the array postfix. We then change the infix to the postfix. Step 1. Step 1. Change the infix to the postfix a plus b plus minus c plus d. D operator in the stack, hashtag, hashtag minus, hashtag plus, hashtag plus minus plus postfix expression a b, a b plus c, a b plus c, a b plus c minus d, a b a c minus d. AB, Q, AB, Stepan symbol operator in stack postfix expression 1, 2, 3, 4, 5, hashtag A into B, A into B, B plus C into D, D minus E, E, F. Evaluation of the postfix expression in the case content operand instead of the operator. Whenever any operator occurs in the scanning, we evaluate with the last two element of the stack algorithm. Add the unique symbol at the end of the array postfix. Scan the symbol of the array postfix one by one and from right to the left if the symbol is operand. To push into the stack if the symbol is operator, then the pop last two element of the stack and evaluate it. Top -1 operator top and push it to the stack, pop the same process until comes in the scanning of the element in the stack. A postfix expression A, B, C, D, E, F, step 1 symbol operand in the stack 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, symbol 4, 5, 4, 2, $2 plus into $2 $9 3 operation in the stack 45442451642184 84 84 4,9 84 493 84 43 84 12 72. The required value of postfix expression is 72. For checking A into B into C plus D, ESF G minus H 4 into 5 plus 4 minus 2 9 by 3 4 into 5 plus 16 minus 4 into 3 84 minus 12. Convert the post file step 1 2 3 4 5 6 7 8 9 10 11 12 symbol operand in the stack postfix operation A plus B A plus B plus C A plus B plus C D. The required postfix expression A plus C into D E F F G into dollar sign infix step one symbol operand in the stack 1 2 3 4 5 6 7 8 9 10 11 1 2 3 4 5 6 7 8 operand in the stack 1 2 3 3 9 9 4 9 4 3 1 3 1 8 8 2 8 2 1 8 3 24. The given infix expression A B D E F plus C 1 plus 2 into 3 4 minus 3 4 into 2 3 into 3 minus 1 3 9 minus 1 3. Q is an ordered collection of the item from which item may be deleted at one in called the front, and the queue and to which the item may be inserted at the another in called the rear of the queue. Deletion front rear you insert and queue 5 0 1 2 3 4 front 1 empty queue rear front 0 adding the item into the queue rear 0 10 front 0 adding the item into the queue rear 1 10 15 front 0 rear 2 adding an item into the element front 1 deleting an element from the queue rear 10 15 20 front 1 rear 3 from queue front queue rear queue from we can see rear item may inserted rear and deleted in front of the queue. Thus the queue follow people policy fast in fast out. Queue as an ADT abstract queue. Abstract MPT queue post condition MPT queue precondition MPT post condition abstract insert queue in type post condition insert queue implementation array implementation linked list array implementation of the queue or queue are the two pointer front and the rear pointing at the front of the rear element in the queue and there is no place for adding element in the queue, and then this is called the queue overflow, and there is no element for deleting the one queue, then the value of front and the rear will be minus one and will be greater than rather 0 1 2 3 4 5 10 front 1 t is equal to 1 rear is equal to 1 operation in the queue add operation if rear max minus 1 print f queue overflow else if front rear plus 1 queue delete operation if the front rear print queue underflow return yields element is deleted from the queue front drawbacks 0 1 2 2 3 4 5 10 15 front to rear. Here we can see the rear is the last position of an array in the front is not zero. We can add any element in the queue because of the rear at the 1 minus 1. Here are the two space for adding the element in the queue, but we cannot add any element in the queue because there is the last position of the array. Algorithm to insert the element in the queue. Row deletion is step 1 stack overflow condition. Step 1 check underflow condition if rear if f follows 1. If underflow step 2 increment the rear pointer remove an element in certain element check for an empty queue set the pointer circular queue is in which the one in certain of the new element is done at a very first location both queue and last location of the queue is full of consider CG 0 1 2 3 5 10 15 from rear 1 rear 3 initial queue 10 15 from 2 rear 3 trigger deletion queue addition queue rear 1 rear 2 deletion in the queue आज अब 20 पन्ना जति पढिएको छ अब ब्रेक फेरि पनि हामी पढ्नेछौँ